We now wish to investigate solving equations that involve roots. We have an algorithm or directions to solve equations that involve roots. Step 1 is to isolate one root on one side of the equal sign. Step 2 is to raise both sides to a power that will clear the isolated root. Step 3, solve the resulting equation. And step 4, check the possible solutions. It is important to check your solutions because of step 2, where we raise both sides of the equation to a power. It is possible that even without making any mistakes in your process, some of the solutions you get at the end may not actually be solutions to the equation that you started with. So always check your solutions when you get to the end. So for example, the square root of x equals 8. We already have one root isolated on one side of the equal sign. So now we're going to raise both sides of this equation to a power that will eliminate this square root. Well, this is a square root, so to eliminate that, we want to square both sides. So squaring both sides of this equation gives us x equals 64. And since we did about the simplest problem you can come up with, we're already done. We've now solved for x equals 64, and if we plug x back into the original equation, we get the square root of 64 equals 8, which is true. Now consider the square root of 2x plus 6 equals 6. So again, we have a problem that already has the root isolated on one side of the equal sign. So now, since this is a square root, we're going to square both sides, giving us 2x plus 6 equals 36. And now we solve this linear equation. So subtract 6 from both sides gives us 2x equals 30. Divide by 2, we get x equals 15. Now if we plug x equals 15 back into the original equation, we get 2 times 15, which is 30, plus 6 is 36, and the square root of 36 is equal to 6. So x equals 15 is in fact a solution to this equation. Now let's look at the square root of 3x plus 3 plus 10 is equal to 4. So we want to isolate this square root, so the first thing we're going to do is subtract 10. So 3x plus 3 inside the square root is equal to negative 6. Now at this point you might already notice that there's going to be an issue as we progress through this problem. That is, we have a square root equal to a negative number. That's going to be a problem. But let's just say you didn't recognize that and we move forward to solve this like usual. We would now square both sides to get 3x plus 3 equals 36. Now subtract 3, we get 3x equals 33. Divide both sides by 3, we get x equals 11. Now if we go back to the top and plug 11 into our root, we're going to get 3 times 11, which is 33, plus 3 is 36. The square root of 36 would be 6, plus 10 would be 16. That is not equal to 4. So x equals 11 is not a solution to our original equation. So we cross that out. In fact, since that was our only possibility, we get no solution. There is no solution that makes this equation true, not in the real numbers, which is what we're restricting ourselves to at the moment. And this is a good illustration of why you always have to check your answers. Our algebra is completely sound. We got down to the bottom to x equals 11, and that still wasn't a solution to the equation. And the reason is from right here. The square root of 3x plus 3 equals negative 6. We know that can't happen in the real numbers, but when we take that step 2 in our algorithm, which says to square both sides of the equation, that problem is eliminated because when we square the right side, it becomes positive, and we get a linear equation that is solvable. The only problem is the solution we come up with is not a solution to the original equation. So we just settle for no solution.